Hello everybody and welcome back, and in this lecture we will start by coding our advanced packet sniffer. Now by packet sniffer I mean some tool that will perform the network analysis for us on our own machine. So this is not something that you can actually use in order to hack something or brute force something or do something like that, but I found this program because I actually had it for a long time right now. I don't even remember from where I got it. It's been sitting on my laptop for a few years, and it is a really good program in order to get the in order to understand the packets on a more detailed and on a more advanced level. So this is for sure not a program that we will code for the beginners. So if you're not if you are a beginner, make sure to actually get everything else done, then you can come back to this. Also, you will need to do some actual learning on the side here and there. I already have the program right here on my laptop. We will code it together for the best practice, and I will explain everything as we go. What this program will do is it will actually run an analyzer of all the packets that we receive. It will split them in fields. But you might be asking right now, aren't we doing that all the time in the previous section with the actual Scapy library? Well, the thing is, right now we will not be using the Scapy library. We will be doing everything manually and trying to get the packets and fields and all the necessary things printed out by ourselves. We will not use some library that will help us do that. All we will use is the socket library, which is low-level networking or low-level network programming. So let us start off by actually calling this program. We will call it, for example, packet sniffer. So let me just go out of my local networks. Now let's make a directory packet sniffer, since this will most likely be the biggest program that we will actually code from now on. And let us call it, so go to the packet sniffer, change the directory to the packet sniffer. And right now, since we call the directory the packet sniffer, we can call this sniff packets.py. We will make user bin Python. Now this is not really a sniffer that you can sniff the usernames and passwords. As I said before, this will give you an in-depth knowledge of actual protocols, the protocol fields, the Ethernet headers, IP headers, TCP, UDP packets, and so on and so on. So first thing we want to do is first of all import the necessary libraries, and as I'm seeing right here, we will need 4 of them. So one of them is the socket library. We can import it with the import socket. We can, we'll need 5 libraries. So also we will import 2 libraries that we didn't use before, I believe, which one of them is OS and one of them is the sys library. The next thing we need to import is the struct library, which will allow us to actually separate the fields of a packet that we receive. As you remember, previously we saw the struct library table, which allows us to actually specify the number of bytes we want to take in a certain variable or something like that. We will be using that right now extensively. And also we want to use the bin ASCII library, which you specify with the actual .I. So first of all, before we do any of that, let us check out if we have all of those libraries in our Python 2. Import bin ASCII, it is there. Import struct, import OS, sys, and import socket. So these are all standard libraries, so you will actually probably all have them. In case you don't, you can just run a standard pip install and then the name of the library, but you will not need to for this program. Now I must admit I don't really remember what this bin ASCII library is for, but once we get to the actual function from the bin ASCII library, I'll make sure to tell you. So first of all, what we do in this program, we will create the main function which will perform the entire process, and it will call some other sub-functions which will actually analyze different types of actual packets. So for example, we will have a function that will analyze ether header, we will have a function that will analyze the IP header, the TCP and UDP also header. So first of all, we want to create the global socket object, which we will use since we will use it in every other function as well. We need to set it to be a global variable, so call it global sock underscore created. And you also want to create another actual socket, which will be global sniffer socket. So it will be a global variable as well. So make sure to specify global before giving it any value. And what we want to do is actually, first of all, make our sniffer socket to be a socket object, and we can do that with if sock underscore created equals to, for example, false. Now you might be asking, why are we setting it to be equal to actually false? Well, before we actually call this function, what we want to do is before the main function, we want to specify that the sock created, so sock underscore created, will be equal to false, and the sock, or pardon me, sniffer socket, we called it like that, will be equal to 0. So we said the sniffer socket will be equal to 0, which it means we didn't actually set the socket object yet to this variable, and the sock created will be equal to false, so we can perform this part right here. So if sock created equals to false, it will perform something in the if loop. Since it is equal to false, we will code the part that will perform for sure. So let me just tab this till the end. And what we want to do is actually make our sniffer socket to be a socket object. We will use socket.socket, and in there we will use socket.pf underscore packet. We will use socket.sock_raw, so we can use actually the entire raw packet, and we will also specify an option socket.htons, and in there 0x003 or 0003, pardon me, I always forget 10. So what you want to do right now, what this means is, what we want to do is take the entire packet and we want to do what we want with it. Basically the 0x003 will be the Ethernet packet, which we will then analyze in more depth for the IP headers and other headers as well. Now what you don't want to do with this actual socket is you don't want to perform the bind function, since this is an actual raw packet or raw socket, however you want to call it, and it should not be bind to any specific port. So we are not going to perform the bind function. All we want to do right now is actually set the sock underscore created to be equal to true. So we successfully set our sniffer socket to be equal to this socket object right here. We set 3 different functions to it, and after that we set the socket created to be equal to true. All we want to do right now is receive any data from our ports, which we can do with data underscore receive, which will be a variable that will store the data, and we will run a function receive for that variable. So sniffer underscore socket, which is the socket object, oops, not another equal, we want to specify dot receive, and in the brackets right here, since I don't think we actually use this function receive, or we might actually use it in the port scanning section, but what this function actually takes as an input is the number of bytes that we want to receive from our actual server, or from our ports in this case, so 2048 bytes. That is the number that we want to receive, and after that all we want to do is actually clear our screen, which we can use the OS function, or OS library, pardon me, which we import, I believe, for the first time. This library right here has a function called system, so os.system, which allows us to execute system commands. Between the brackets, all we need to specify is clear, since this is the actual command that we use to clear our screens. And after that we want to use our data receive in order to analyze further on our Ethernet header. So what we will do is, first of all, we will tab data underscore receive and IP underscore bool will be equal to the analyze. Let me just check this out. Analyze ether underscore header from the data underscore receive. Now basically this analyze ether header is a function that we will code right now. This is not a function that actually exists. We need to make it before we actually do anything else, and it will store the data the returning value to the data receive and to the IP bool, which the IP bool will actually take the value of true or false. So all we want to do right now is actually code the function the analyze Ethernet header, which we will do right here. So def analyze underscore ether underscore header. It takes an input of data underscore receive. So, whoops, I can't type. So it takes that value, and first thing we want to set right here is the IP underscore bool to be equal to false. Now if the function performs correctly, we will set at the end the IP bool to be actually equal to true, and then we will proceed with our main function further on. So first thing we want to do is something that we did in the previous videos, which is actually extracting the Ethernet header. We will use the same command, which is the struct, which is the actual function that we will use from the struct library, which will allow us to actually take the first 14 bytes, which is the amount of bytes that the Ethernet header can store. So we will use a variable called eth underscore header, and then we will use the function from the struct library, so struct.unpack. And if you remember, this function actually takes two inputs. One of them is the actual pattern for specifying the amount of data, and the other one is the actual data from which you want to take the value from. So first of all, between the double quotes, we will specify the same thing as in the previous videos, which is 6s6sh, stands for actually specifying from the struct tables the amount of data we want to actually extract. Then in the comma, after that we need to specify from where we want to extract it. We want to extract it from the data underscore receive. We want to take the first 14 bytes, which we specify with this right here. These two dots, if you remember, means take everything from the beginning, which is from the first or from the 0 element to the 14th element. So once again, this basically unpacks what we got from our sniffer. Since this is the first 6s represents the MAC destination, the second 6s represents the source destination, and these 2 bytes basically represent the protocol attached to the Ethernet header, which we most likely are going to get the IP protocol, which we actually want to get and analyze further on. So this is just us extracting the Ethernet header from the packet. Now what we want to do is actually extract the destination MAC address and the source MAC address and also the protocol itself. So how we can do that? We can just use a variable called dest underscore MAC equals to, and here we will use first time the bin ASCII library. We will use a function called hexlify, which will actually take our destination MAC address and it will turn it into hexadecimal. What this will allow us to do is actually print the MAC address in a different manner than in the previous videos where we actually use the %x in order to print different values of MAC address. Now if you have no idea what I'm talking about, don't worry, I will show you just in a second, but first of all let's define this variable right here with the bin ASCII.hexlify. And in the hexlify we need to specify, since the destination MAC address will be the first 6 bytes from this 14 bytes Ethernet header, we need to specify it to be Ethernet underscore header, and we need to specify the first element. As we said, that will be the first 6 bytes. We need to do the same for the actual source MAC address, which we can just store in the actual variable called source underscore MAC. It will be equal to the bin ASCII.hexlify, and this hexlify will take an input from the second element, which will be the source MAC address, so Ethernet underscore header, and the second element, which will be represented under number 1, and we close the brackets. This is the actual source MAC address from our Ethernet header. All we want to do right now is also select the protocol, so proto will be equal to Ethernet header, and then we need to specify the number 2, since this is the third element, and basically we will specify it to be in the number 8. Now I must admit I'm not really sure why right here we are using number 8. Okay, so basically the 8 will be the IPv4, since we want to actually get the IPv4 protocol later on, since we are analyzing the IP header after that, so make sure to specify it the same as I did with these 2 arrows pointing to the actual 8. And after that, let me just show you right here, we need to take the data to be equal from the remaining data of our packet. So we use the entire packet, we stripped the first 14 bytes, we actually took the different fields from our Ethernet header. As you can see, 3 different fields, each one of them taking the different amount of bytes, except this destination and source MAC address. And what we want to do is strip the remaining data to be equal to the data underscore receive, and then from the 14 byte and then further on. Now what we want to do is actually, in the next video, what we will do is we will print the statements where we will actually say that this is destination MAC address, this is source MAC address, and this is protocol. Then what we will do afterwards is we will actually set or check if the protocol is equal to the 8, and if it is equal to the 8, that means that it is an IPv4 protocol. We will select the IP bool value to be equal to true, then we will return the data, which will be set to be from the 14 byte, and we will return the IP bool, which will be set to true, to our main function, and then afterwards we will check if bool equals true. If it is equal true, that means we got the IP header next, and then we will analyze the IP header. So that will be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye!